Welcome to Down Ancient Trails, the online archaeology forum of the Sharma Center for Heritage Education, India. Brush the dust off long forgotten thoughts. Slice through time and space.
Listen to stories in stone.
Whispers of voices lost in time.
Build bridges across worlds.
Curious minds reach out to the past. And travel down ancient trails.
Good afternoon to everyone present here and to this forum. Today I'm going to talk on zinc production in ancient India. That is Zawar. This is actually world's oldest zinc production center, located very close to Udaipur, just 40 kilometers to the south of Udaipur. Udaipur is in southern Rajasthan, and I chose to speak on zinc simply because though other metals like copper, gold, and iron, they are all equally important. Maybe some of the metals like you may say iron is far more important because it is far more used than any other metals in our life. But I have chosen zinc to talk because it has brought a big name to the country. Of course, iron has too, but then zinc has stolen the show. How? It is a volatile metal and very difficult to smelt. Pottery has this metal has a beautiful poetry. If you are smelting non-volatile metals like copper and iron, they would settle down in the furnace,
Hello,
would come.
Jeevan.
Yes.
Jeevan ji, one minute. They're not getting an audio they're not getting an audio, but I'm getting. Some participants were saying there's no audio. Can you please check? Because rest of us are getting.
Just wait.
I think it's
I
clear
have
to
not. I
me.
have not clicked anything mute or unmute.
No. I think you are fine, Jeevan. I can hear you, but some participants said that they are not getting the audio. Is
Okay.
it okay now?
I can just, if
Yeah, just
maybe I
just
can
hold.
try this closer to my mouth. Maybe then.
Yeah,
Uh,
okay, great. I think it's great now. Everyone seems
okay.
to be hearing. Okay, fine. Could you
Okay.
just go back a slide, please? I'm sorry to bother you about
It's
that,
all
but
right.
some
It's all
could not
right.
hear.
It's all right.
Okay.
Okay, friends. Today I have chosen to speak on zinc because it is a very difficult metal to handle. Compared to other metals, other non-volatile ones. In metallurgy, the early metals, of course, are copper, bronze, gold, lead, silver, etc. Of course, if you talk about the history of metals, then ever since we see the early man on the earth, or the entire history of man, the total history of metals would be just a few seconds. But then, ever since metal came to hand, so within no time, we had civilizations, large settlements, urban features, etc. But in that case, if you look at the history of other metals, then again, zinc comes at the end, and it has a very short history. Being volatile, unlike other metals, it is very difficult to smelt, because what happens, if you are heating things like iron, copper, they would settle down in the furnace. They are heavy and come out in semi-liquid, or say hard, or hard form, solid form. But if you are heating zinc, it is a volatile metal, it gets lost. So therefore it is very difficult to handle it. In ancient days, it was primarily used for making brass, and since it was a prized metal due to its scene, and on top of everything, being an issue of our scientific heritage, it brought big name to the country. Therefore, I thought, why not to talk on this issue? Because not many people read about it, talk about it. It is not there in our syllabus. Therefore, I thought we should talk about it, because many people talk about iron and copper, but not many about zinc. Well, if you see the geographical distribution of zinc in India, you see this ore. This map is based on geological memoirs or the reports from GSI people. You see, zinc is in Kashmir. Lead zinc generally occur together. They are in the Himalayan region. They are in northeast. They are also in parts of Odisha, also in peninsular India, like in Andhra Pradesh. But then the major deposit is in the Aravallis. That too in the southern margin of the Aravallis. And the only economic exploitation could happen in the past only in the Aravallis. This is the geological map of the Aravali, and the Aravallis are supposed to be one of the very old rock mountain system, which is at the base. Actually, we have Precambrian gneissic rocks, and then these gneissic rocks are superimposed by three different layers of Delhi supergroups. Among these three Delhi supergroups, the second has lead zinc deposit largely. If you look at the Aravallis, they are moving diagonally from Delhi to Ambaji in Gujarat. And if you see the eastern margin of this Rajasthan map, you see number of dots, and these dots, represent a large number of ancient mines and of different metals. So the northern part aspect of the Aravalli is largely dominated by copper deposit. The central one is with lead, and the southern with zinc, and of course copper, and in some pockets there is iron too. It is more like Aravalli is more like a polymetallic zone, like Anatolia, and the southern aspect of this Aravalli, which I have encircled in this map. This is actually the area of zinc production center where Zawar is located. And here, if you see the experience of iron metal making, goes back to last 4,000-5,000 years, because the early farming cultures are known as Ahad and Ganeshwar people in the Aravallis. Well, what happens, when we talk about zinc, then what do we do with that? Actually, zinc was used in the old days, in old world, only primarily to make brass. So what happens, brass has even older history, longer history than zinc. How? Because brass can be made accidentally, it can be intentional, it can be deliberate, it can be by mixing copper and metallic zinc. Now, what happens in accidental case? If it is, you do not know if you are making brass, but you do not know a selection of the ore, then the quantity of percentage of zinc would be less than 4 in that case. But if it is you are selecting the ore, in that case, it is going to be, it may happen more than 4%. And in case of deliberate brass that includes the cementation, it is a closed actually smelting. In that case, the percentage of zinc in copper would be less than 28. But that 28 is quite a bit good amount. And this is deliberate brass. And if the percentage goes beyond 33, that means zinc was first obtained as metal, then it was mixed to copper. So this is something different. And in that case, the percentage of zinc goes beyond 33. So this is a clear evidence of zinc making. So if we have this this is scientifically proved and had been well published. So since brass, doesn't corrode, gets rustication, corrosion due to zinc, therefore it became a prized metal in ancient times. And if you see the history of brass in India, though it has not been sung well, but then we see experimental stages or early brass objects from sites like Hastinapur, sites like Lothal. Lothal has one brass, object in which the percentage of zinc is more than 4. But in case of Hastinapur, And even in Aichhatra, there are objects in which the quantity of zinc is more than 4%. That can be taken, these two, three sites can be taken as experimental stage. I'm not claiming that, actually people knew about brass. It may be external, but then it may be selection of ore too. Here I just, I'm showing you the sites where Hastinapur, Ataranji Kheda date back to 1200 BC or around first millennium. If you go to Lothal, that is a Harappan site in Gujarat, very close to Ahmedabad. That goes back to urban phase. Then there is an evidence from Takshsila, which is in Pakistan, northern Pakistan, where a brass, where evidence of brass has come, goes back to late 4th century or early 3rd century BC. And then there is another site in Middle Ganga called Senuwar, where brass bangles have been discovered dating back to 2nd century BC. And then there are sites like Nalanda, Vihara of Nalanda, Timargarh graves. Then there are brass coins even of Gupta kings, and so on. So the history of brass comfortably goes back to around early centuries of the Christian era. Then we do have, large number of, brass making centers of medieval times and pre-modern times also across the country in many places, even ranging from Bengal to
Jeevan, I think your volume has gone. Jeevan? Hi, Jeevan. I think
if you have
your volume went. Can you go back a bit? Your volume
there
went
was
in between. Yeah.
Sorry, there was a call in, I disconnected it, therefore maybe.
Okay,
Sorry.
okay.
Sorry. As I said earlier, what is interesting is the site of Takshsila, where the Romans arrived in late 4th century. So what happened? Actually, prior to their arrival at Takshsila, there was a village.
Oh, Jeevan, I think you have snapped again. Jeevan ji, I think his connection has gone. So we'll just try to get him back. Jeevan?
Actually, sorry.
Yeah, okay, your connection has gone. Can you be a bit, hold the mic a little bit away from the mouth?
Okay.
Yeah, and your connect, yeah, fine.
Is it all right? Is it all right?
Yeah, it's okay.
Hello?
It's back again. Your video is back again. Yeah.
Okay. So now, if you can see this Takshsila, analysis, it says in one of the object called waste, the percentage of zinc is 3.4 to 3.4. This is damn interesting. It is 3rd century BC at Takshsila, when the Romans had, not arrived. There was a village, and in those villages, this metal object is. That means people at Takshsila were able to mix metallic zinc with copper. So making metallic zinc is a very, very difficult issue. So this we will learn in coming slides. And similar situation is in Senuwar, where you have bangles of brass, the amount is 35.52. This is also damn interesting. Senuwar is in the Ganga Valley, Middle Ganga Valley, where you don't have any zinc deposit around. The nearest would be the mines in Bihar. So that is going to be too far again. So how did people obtain this metal there is an interesting issue. Why brass is important? Because it looks like gold. It doesn't get corroded. It has a long life. Therefore, possibly this zinc became very important in ancient times. Even people in many religions, including Buddhism, Hinduism, they also used it for number of time for icons also. You might have seen large number of iron cannons across the country, but you might not have seen brass cannon. Here at Udaipur, when you come to Udaipur, right at the bus stand of Udaipur, in front of the bus stand, you have a brass cannon. Brass cannon can happen only when you have zinc, otherwise not. And here you see these brass, door handles. These are very common across the country. We do use them because, they do not get corrosion, and it is because, since zinc is there, it is helping to protect them. So since zinc, gives long life not only to the metal, also to the life. Therefore, it is called yasad. The name yasad came much later. We will come down to that later on. But if you are hit, if your any part of your body is cut, then doctor gives you some medicine, prescribes you some medicine that always has zinc. So zinc heals up and gives you long life. So therefore, it is called yasad. So then we have now, if you see the textual references to brass, then we have very good reference in Arthashastra. Kautilya refers to brass as then you have lots of alchemical and iatrochemical texts ranging from 8th, 7th, 8th century to 14th, 15th century, like Rasratnakara of Nagarjuna, then Rasarva Rasvarnam, then Rasratna Samuchaya is a very, very well-known text. Then there is hello, can you hear me? Hello, the voice is gone. Hello. Hello.
Hello, Jeewan ji, can you switch on your audio? Yes, fine. Now it's okay. Your voice, can you hold the mic a little bit away?
Okay.
It's fine otherwise. For me, it's fine, but some people were having trouble.
Oh,
Okay,
sorry.
but it's fine. It's fine for most, I think. Some were having trouble. Okay, great.
Okay,
Please
shall I
continue.
go back or
No,
continue
it's
with you?
fine. It's fine, I think.
Okay.
Yeah.
So, for brass, there have been copious textual references, in the ancient world. We have right from our epics, even in the Indian Materia Medica, in Ayurvedic text, even in Arthashastra, we have references to brass as arkut, and then in the later alchemical, which starts from 7th, 8th century down to 14th, 15th century, when we come to iatro alchemical and then iatrochemical text, then we have very, very important, text like Rasratnakara of Nagarjuna, Rasnava, Rasvarnam, then there is Rasendra Chintamani, then there is, by text by Yasodhara, then there is Rashtrata Samuchaya, and there are, besides these, there are, Chinese, Persian, British, and Greek texts also, which refer to brass, because brass, even Chinese were using, even Romans were using. Roman brass goes back to 3rd, 4th century BC, and people know that Roman brass is quite famous. And the Chinese also knew brass, but not later than 2nd century AD. They do not have any history of brass earlier than 2nd century BC. This is one early example coming from our Materia Medica about brass again. It reads, Suvarna Rupi Puta Tamra Riti Kansisti Statru Mavenu Dantehe. You see, this riti word is for brass here. So in the ancient text, riti and arkut, they have been used for brass. This is coming from Siddhisthana of Charak Samhita. Then again, you have another reference to brass there. Soviranjan Tutham Tapyo Dhaturmana Sila Chakshusya Madhukam Loha Manaya Pospanjanam. This Pospanjanam is, white flower actually. Then this is Shukla and Tripathi have interpreted this as bhasma, the powder of metal of Soviranjana, perhaps made of lead sulfide, tutham pure tutiya, gold pure mansil, and then vankuthali, mullet, iron, and pospanjana are mild in taste and good for curing eyes. The word Puspanjana of the text has been interpreted as a white surma or flower of jasta or rasaka or kharpara jig. So this may be one of the early texts referring to zinc, maybe. But then there is, after coming to alchemical and iatro chemistry, we have following Ras Ratnakara, this Bhav Prakash Nigantu is another very, very important text coming from Gujarat, where also used Dwarkut. It is Arkut. It is again brass, has been said. So it has Pitala Dwarkut Syadaro Ritisha Kathyate Rajariti, Brahmariti, Kapila, Pingalapi. These, brass has many types. So Rajariti, Brahmariti, Kapila and Pingala, these are different types of brass. Brass was clearly said in this as an alloy of copper and zinc. This alloy has been described for the not only first time but second time. Earlier this was explained very well by Rasratnakara when he also says, Rasratnakara also says that what wonders if we add 2% of zinc in copper, equal amount of copper. What wonders it change into a metal which looks like gold. So that was already said by Rasratnakara. Now there are a large number of text in the words in the text, ancient text, for brass and zinc. For example, in Indian text, you have arkut, riti, ritika, pital, virinch, rotutia. These are for brass actually. And for zinc, Pospanjana, Staupadan, Rasak, Mritika Rasak, Gud Rasak, Pasan Rasak, Kharpar, Jasata, Yasad, Jasat, Yasad. These are the words for zinc used frequently. And then also there are Greek words, there are Chinese, there are Arabic, European. But in what is interesting is that if you are going to China, if you are going to Europe, Tutanag. This Tutanag word is neither Arabic nor European nor Chinese. This Tutanag is a South Indian word coming from Andhra Pradesh for zinc or tutia for copper sulfate actually. And why this is reaching? This is a clear sign of transmission of knowledge or transmission of knowledge of metal to these places from here. And it was denoted for zinc in the during the time when zinc was being actually supplied to these places from India. Then what happened, prior to the discovery of Zawar, we are going to talk about Zawar now. Prior to the discovery of Zawar, there were many places. Santi, am I audible? Is it clear?
Yes. I think it's clear. It's very
Okay.
clear. Yeah.
Okay.
Please continue.
Prior to the discovery of Java, there are many places in the world. If you read the early Bronze Age literature or otherwise literature of the ancient history across the world, where people claim, evidence of zinc like Athenian agora, this is in Greece, then Tel Gazer, West Asia, Middle East, Agoda, Argentina, Namarja Depe, Bern, Switzerland, British Seychelles, then in China, Jinganji, and in these places. But now all these places have been refuted, except for Asia Minor of 3rd century BC, 4th century BC. There is no evidence of older zinc in any of these places. They have been come of a much later date. This is the panoramic view of Zawar, which is in the Arauli Hills, just 40 kilometers to the south of Udaipur, en route Ahmedabad. What you see is here in this picture is a Jain temple, and this is old. This is now called Old Zawar. There are large number of heaps of refractory material in this area, and also large number of ancient settlements, actually remains of houses and furnaces in this area. This is the modern Zawar village, and actually all these area have large number of heaps of refractory material of zinc. These are some of the temples. This area has around 200 temples, including Jaina and Hindu temples, and mostly of Vishnu. Also, there is a temple of Zawar Mata here. This is the stratigraphy of Zawar, I mean rock stratigraphy of Zawar. What you see at the base, this gneissic, complex, granite, and this is superimposed by three different, layers of lower, middle, and upper Arauli groups. And among these three, the middle Arauli group have, rock types like dolomites. This part is denoted as dolomite. This has got lead zinc and lead zinc deposit primarily, whereas the lower one or the upper one doesn't have. So it is other than this, and this in this it has, this area has lots of faults and folds in the rocks, and this area is composed of ridges and low hills, and has lot of faults. Therefore, you have this kind of deposit in the shapes of lenses. You have deposit of lead zinc in the associated with dolomite rock. So this kind of lenses of lead zinc deposit, whatever is shining here is lead actually. What you see shining patches, dots, this is lead, and remaining is zinc. Uh, well, many of you may be knowing these people. This in the center, this person is Professor Bhan. You know, Kuldeep Bhan from Baroda University, who is retired now. This is Professor Sonamane with glasses, and this is Professor Ajit, who is also retired now. And this is Paul Kadok's wife here. This is the first discovery of Zawar of a smelting furnace that was done in 1982-83. And people who discovered these places, the discovery started with the initiation of H.B. Paliwal, Harihar Paliwal, who was the then director of Hindustan Zinc. He went to ASI. Deshpande was the director general then, to initiate the discovery of zinc smelting at Zawar, because he had already picked up locations where furnaces where zinc was being smelted, and then with whom Gurjar was a geologist. Then Paul Kadok joined them, KTM Hegde from MS University, Lynn Willis from England, then Sunamane, Krishnan, Morgan, Ajit Prasad, Brenda Kadok. All these people started working in 1982-83, and they continued for Paul Kadok, Paliwalji, Gurjarji. They continued for a couple of years, including Lynn Village. Other people, MS University people, later on shifted to Gujarat, but then initially they were there. And this is their first discovery, or the major discovery, of bank of 7 zinc smelting furnaces at Zawar, which was amazing because it was never found anywhere in our globe. This is the small team. Another picture. This is H.B. Paliwal on the left. Then in the center is Paul Kadok from British Museum, London. This is KTM Hegde in the center. And then this is Professor Krishnan. And then last is Ajit Prasad. So this was the team which started work and excavation work there, and discovered this amazing discovery, did this amazing discovery. This is the excavation going on at Zawar. And what you see is the perforated clay plate and some bottles, actually clay bottles, terracotta bottles, actually, which are called retorts. They're unique retorts. They are actually brinjal-shaped retorts, kept upside down on the plate, and they had a nozzle, which you will see in the coming slides. Then this is the partial excavation of the furnace. So they discovered 7 furnaces together, and in course of survey, it was realized that at Zawar there are either 3 or 7, or mostly 3 furnaces together, or sometimes 7 furnaces together. They found this at a couple of places. So in 7 furnaces, in one furnace, 36 retorts, these clay bottles, were kept. So in 7 furnaces, 252 retorts may have been kept. I mean, this means this was giving a strong indication that it was part of chemical industry. What you see here, small low mounds. Actually, what happened when they mined zinc in that area? I have a long section on mining. I'll show you how mining was done. But what happened once they mined ore, from these dolomite rocks, open and deep underground ones? Then what they did, they roasted the ore first. After roasting, they removed sulfides, and then they to get zinc oxide, and to that zinc oxide they took it to the bottles for further smelting. When they roasted the ore, and then whatever was discarded, this is the discard of that roasting. You have large number of such heaps around in Zawar, which is just remains of roasting. These are large circular pits for, after roasting, actually the ore was grind and it was made powder. but, that powder was eventually mixed with cow dung, raw cow dung, to make small balls to insert in the bottles. So these such bits were used for grinding. So this is, sketch of the furnace, how the furnace was actually. You have this square furnace, 69 centimeter by 69. It is a square furnace. In the center, you have these four terracotta plates. They are just 6 centimeter thick, and these have, smaller and bigger perforations. And these are in these are in four parts joined together, kept on top of this furnace, and there is a clay stick at the base, and eventually it will look like this. And on top of this, the wall would go further up, and the bottles would be kept upside down. They'll have a nozzle. The nozzle would go to the lower chamber. That means the furnace had two chambers, upper and lower. We will see the upper chamber later on, but this is just the lower chamber of it, where actually zinc was collected in the form of powder. How it was done, we'll see this later. So these are the actual remains of the furnace. Now you can see here bigger perforations around which smaller perforations are there, and in the nozzle of the retort, brinjal shape retort, was inserted in the this bigger hole only. So you can see this broken furnace here on the left side. So this clay stick you can see here. This is profile of the furnace. The bottles are kept upside down. The nozzles are coming down. This is the lower chamber of it, and this is the upper chamber. Once the retorts, the charge was full, these were filled, and these bottles were kept upside down in the furnace. On top of these bottles was filled lot of fuel like charcoal or cow dung, or fuel to heat, and ultimately the furnace would have looked like this. So this is the sketch of Paul Craddock, or Brenda Craddock, actually his wife. So the furnaces may have looked like this. This is Brenda Craddock's work. So at Zawar, the furnaces may have looked like this. Uh, well, when they prepared the bottles, these are unique bottles again. The lower part of the bottle, actually, here it is the upper part. The clay balls, small clay balls, maybe the diameter of those balls was not more than 2 centimeters. These clay balls were filled in, then the cap, the upper part, or here the lower part, was fixed together, and it was luted like this with clay, and then ultimately this was placed in the furnace. So the summary of the total operation is this way. First mining was done, then beneficiation was done, I mean separating the impurity from ore, then it was roasted, and after roasting the grinding was done of the ore, and then once it is grinding, it is powdered, then it was mixed with raw cow dung, and then sometimes some other agent, because when you do it in the laboratory scale, some other agents are given in the ancient text, which I have placed in the coming slides. Then preparation of small balls, filling in those balls in the bottles, and inserting a wooden stick. A wooden stick would be right from the nozzle, end of the nozzle, up to the end of the bottle inside, so that nothing falls out when the bottles are kept upside down. Then finally luting the cap, placing it in the furnace. Then the furnace was given heat 5 to 6 hours with the temperature 1000 to 1100 degree to obtain the vapor of zinc. Now, actually what happens, zinc can be smelted just at a temperature of 415 degree. But it boils at a temperature of around 930 or 945 degree. But if you want to have vapor of zinc, then you have to raise the temperature to about 1100 degree temperature. So raising the temperature to 1100 degree for 5 to 6 hours in those days when they had no fan, no electricity, and that continuous 5 to 6 hours maintaining the temperature may have been a miraculous job, but they did it. Then what happens in some ancient texts, many ancient texts, they give lots of other agents which were, working as reducing agents in the furnace. For example, Rasrata Samuchayar, Ras Prakash Sudhakar, and others, they refers to borax, ghee, treacle, salt, nosadar, earthworms, wool, turmeric, cherry plum, cashew nuts, cow dung, all these things were being added to obtain when this zinc was being done at laboratory scale, because initially when people started making zinc, it must have been when it was started using for Ayurvedic medicine. Actually, the history starts from Ayurvedic medicine. So when it was being done for Ayurvedic medicine, maybe these kinds of agents may have been used. But when you are making it in a chemical industry form or in a commercial form, maybe then it is difficult to use all these things at such a large scale. Maybe in that case, maybe cow dung would have been one of the easiest thing to add. So all these reducing agents also help to create carbon monoxide in the bottle. So these texts also clearly explain how the bottle was prepared, what was the measurement of the bottle, how it looked like. Prepare a brinjal-shaped musa. Bottle is called musa, retort of clay, with 12 angul. Angul means finger. Long tube fixed over it, like an inverted datura flower. Make a hole at the height of 8 angula in tube. This is used for extraction of stove, metallic content, from the soft drug like kharpara, zinc ore. This is published already in Indian Journal of History of Science in 1991, volume 26. So you can see it. So these are the actual bottles. These are the actual retorts, musas from Java. And their nozzles is broken here. The nozzle was about 13 centimeter long. So, and the nozzle was looted to this. And in most of the cases at Java, you do find bottles, but the nozzle is missing or it is broken. This is on the right side is part of that nozzle which you see here. This retort is cut across. Now what you can see, the retort is made of local clays to which lot of thick thick grain stones, cobbles, they have been mixed. So, and you can see the analysis of bottle here. Of course, the analysis of a charge which is exhausted one. So what remains here now? It has zinc very little, then it has lead very little. So these things may have been already exhausted. So a furnace, complex may have looked like this. This is again a sketch of Brenda Kadok. So people at Zawar may have been doing activities something like this. So maybe the direction of air or the time and direction of the air may have been very, very important for smelting zinc, because they need air for 4 to 5 hours to heat a furnace constantly and maintaining the temperature to about 1100 degree temperature. Otherwise, things will not happen. What our Rust Ratna Samuchaya, which is largely published by again in our National Science Academy, it clearly explains how actually the charge was prepared to fill in the bottles, and when it is being heated in the furnace, then what happens when it reads. I'm not reading the entire text; it is too time consuming. But then, it reads, when the flame issuing from the molten calamine changes from blue to white. Where can you see that flame? Because the upper part of the chamber would be closed. Only in the lower part, where the nozzle is coming out in the lower chamber, there only you can see. From the open part of the lower chamber, you can see that what you see when the flame issuing from the from the molten calamine changes from blue to white, the crucible is caught hold of by means of pair of tongs, and it is mouth held downward. Then it means your zinc is done, your vapor is out, and you can take out that bottle. So this is already registered clearly in 13th century AD in Rust Ratna Samuchaya, how the zinc was made in ancient India. In Rust.
I think even your audio has gone. Jeewanji, I think you're frozen.
Scale, zinc was made by.
Yeah.
Sorry, due to call there may be disconnection. Also,
Okay.
we have in our alchemical and iatrochemistry text, we have exactly similar kind of apparatus. The way a furnace was made at Java, in the same pattern, on the same principle, we have a picture in the alchemical text. It is a downward distillation actually. Now, for heating again, the text clearly says what has been concluded by by P.C. Ray. P.C. Ray's book is very famous written in 1905 and then revised in 1956. Clearly says that 4 to 6 hours to complete the process of smelting, and it produced one furnace had 36 retorts, 20, and each retort could have accommodated 1 kg of charge. So that 1 kg of charge could produce 20 to 36 kg of zinc from one furnace at one time. So if there are 7 furnaces, so that means you can multiply it by in one shot how much of zinc was being produced. Then carbon monoxide issued from the condenser when from the nozzle the carbon monoxide is coming out, at the end it will also burn with some zinc, while when the flame is blue, green, and then ultimately eventually turning to white. When the flame changed to white, the charge was done, exhausted, our process is over. This is clearly explained in the alchemical text also. Now, why the idea came to the people of Zawar, for downward distillation? It is because, in our country, there has been a very long history of making country liquor. People, if you go to south, if you go to north, go to east, go to west, we have everywhere, there is a very strong tradition of making country liquor. So here again, this country liquor process has also been explained in the Materia Medica, because in Materia Medica, people, the scientists, the doctors were making medicines using distillation technique. This is basically a distillation.
Jeewanji, I think your video has gone. I think he's switched off. Please bear till he comes back. Jeewan, just give it a.
Yeah, it's gone.
Which try to get him back. I think he's coming back. Jeewanji, we need your audio. Yeah, we need. Wait, I'll unmute. Yeah. Okay, you're back.
Okay, done.
Yes, done. Not a problem. Not a problem.
Okay.
Yeah.
Sorry.
No, don't worry about it. These things happen. We all have to get used to this new life. We are not used to being online. Now we have to get used. So please don't worry about it. Carry on.
Okay.
Yeah.
Okay, so this is the country liquor making, very close to the area of Zawar itself, where the downward distillation is being done and the vapor is being condensed actually in this water area, where they have a pot here and it is being heated. It is getting heat here, and the vapor is coming down this way through this pipe, and ultimately the spirit is being collected here. So this very idea of condensing vapor was very much there around with the local people, with the wheels, with the smiths here. Therefore, they translated the idea of this vapor, condensing vapor, into the zinc making furnace, and they succeeded that. This was wonderful, to translate that idea. I'm saying wonderful because we did try twice, thrice, we miserably failed. Therefore, I'm saying it was wonderful. Okay, now uh, Paul Craddock and all those people, they when they worked there, they have whatever they have documented. They say about 600 tons of this refractory material. Of this refractory material is available around, because there are large massive heaps like this in Java, several massive heaps like this, which clearly indicate that for many centuries this zinc smelting was happening at Java. You can see episodes of dumping here, large number of episodes of dumping of this refractory material. Refractory material is actually what, when you are smelting, you are heating zinc in the furnace. Then once you collect the vapor, condense the vapor, get zinc out of it, then those bottles are useless, then they throw those bottles. So when they throw those bottles, the bottles also have charge in it. So the bottles including charge is called refractory material, which is dumped here. All you see these dump, there are several dumps like this around in Java. This was for 800 years. You can see the episodes of this dumping. Okay. Now, sometimes at some places in Java, I mean, when you are walking around, you can see all these structures. These are bottles actually. The Java smiths, or the people, those who were living in Java during these operations were happening. So what they did, when they discarded those bottles, they may use those bottles as bricks to make their houses. These are walls of their houses actually at Java. So they look very beautiful, impressive. Paul Craddock and their team has done large number of radiocarbon dates of mining as well as smelting at Java. So that dates for mining range back to 4th century, 5th century BC down to 18th century. And for smelting, the earliest date is 9th century AD. And then most of the consistency of the dates is bracketed between 12th century AD and early 19th century. So that is the time bracket for zinc work at Java. So also lead. So these are the dates. And then there is some literary record, textual archival record available at Java, for Java, in the archives at Udaipur. This particular one on the left side, so it reads Parishist 7. Actually, it reads 2,50,000 rupees, where was the production from zinc mine of Jawar. So and in one day, 700 rupees was earned. This is a time of Vikram Samvat 1691. So this is something like 1650 or 1640. So at a time, in one day, 700 rupees would be, I think, would be very, very extremely good amount. And another documents reads that it belongs to Vikram Samvat 1713. It also reads 2,49,042 rupees were earned from Java in 1 year. So it is almost same amount, and extremely good amount, I would say. In other words, I would say Jawar must have been a very, very important revenue earning for the kings at Mewar, in Mewar, or for the Maharanas, whom you know very well, the ancestors of Pratap. Jawar has, at Jawar there is a fort. I'll show remains of the fort also. And at Udaipur in archives, we discovered, several, archival record for Jawar it has a treasury, and that treasury had money which was kept in different bags. These are indicative of different bags actually, and the total counting has also been written here. And it has also hundi of Hyderabad. So there is a lot of information about the trade that was happening from Jawar. The zinc may have been sent to number of places, and the treasury was being operated right from Jawar. This is the fort plan of Jawar, and what you see here, this fort is here, and this is the entrance of the fort on the right side. And there are temples around. Unfortunately, this area is ruthlessly being destroyed by the Vedanta group now. They have nothing to do with this heritage. They are just, trying to dismantle this and trying to have their own minds now. These records which I showed you in the previous slide actually belong to 1680 to 1797. So this is 17th and 18th century records actually. Inside that fort, we discovered actually a sun icon belonging to 12th, 13th century. Of course, at the same time when Jawar was flourishing. And this particular sun icon is being worshipped as Holika by the holy deity. I mean, Holi is a festival in India, so Holika is a goddess. So it is being worshipped as Holika in that area. Why I don't know, but this particular legend is associated with the mining area in that place. In Java, in many temples, you do have inscriptions, and these inscriptions have been now edited, now published by one of our colleague called Arvind. He has published, and he reads that these in many of some of these inscriptions also read name of Aurangzeb. There are some Mughal coins also discovered from that area. They're indicative of trade itself. Then you have Jain icons, and you have large number of inscriptions. They have mostly been published now. Okay. Then there is a cave, which is there is a legend of Prahlad here. Prahlad is a incarnation of Vishnu, and is not in the any known lineage, but it is a it comes in the Indian mythology, and the story of Prahlad is connected to Jawar. For some reason we don't know. I was explaining, the production initially. Now you can see in those furnaces, in one bottle, one retort or one musa, 1 kg of charge, out of one bottle, 400 gram of zinc was obtained. So in one furnace, there were 36 retorts. So at one shot, 25 to 30 kg of zinc was obtained in one activity of smelting. So what Craddock and Company Limited, calculated, that estimated that about 600,000 tons of smelting debris at Jawar is recorded, and about 32,000 tons of zinc may have been produced just in 400 years. They calculate it just for 14 to 1800 years, not from 1200 to 1800, not from 900 to 1800 years, and not from Mauryan times, because zinc was being produced at Jawar right from Mauryan times, but they just calculate it for 400 years, 14 to 1800, when it was on the peak for smelting, and that time it was 32,000 tons of zinc. They think if it is calculated for more, I'm sure it must go more than 50,000. Then we have indications and some inferences for trade also from Jawar. What was happening? Jawar is known as Yogini Patan in the local inscriptions. Patan is a suffix which is added to places from where trade is being organized. For example, Visakha Patan or Visakha Pattanam. Or there are places in Rajasthan from where trade was being organized during the medieval time. So the places are, suffixed as Pattan. So Yogini Pattan. Yogini is a tantric deity, and Pattan is the place from where trade was done. So Jawar is also known as Yogini Pattan. And there is residential structures of somebody called Vela Vania at Jawar. There is a story about Vela Vania, who was a very big businessman, who was doing big business with zinc from Zawar has large number of structure on top of one hill right at Zawar. So this is indicative of a trade, maybe local trade. I mean you can say within the country or to different region from Zawar. Of course, trade of what? Obviously zinc. Then we have public record office, from London, 1509 to 919. It reads about the zinc was coming from India. It gives the reference. Then there is somebody called Livavius. He was an alchemist of Holland. Received Indian zinc in 1597 from a friend, which he calls peculiar kind of Indian tin or Malabar lead. This Forbes has written in 1950. Indians have long been in possession of the method of extracting pure zinc from the ore. At least in the course of last century, this metal has been brought from thence to Europe. It clearly indicates that this Indian zinc was already going to Europe in 13th, 14th century. Initially, I told you, the word Tutenag is a South Indian word coming from possibly from Andhra. And in Europe, Genghis mentions the importation of zinc from India in 1647 in his famous work called De Minerabilis. A metal of this kind under the name of Tutenag is brought from thence. So this Tutenag, the zinc was known as Tutenag in the West during this time. In London in 1731, zinc was sold at a very high price, about 260 a ton. 260 pound a ton. It was very, very costly. Looking at the price of other metals or other things in the bazaar then. China records, China has a very famous book. Chinese have a very famous book called Tengung Kaiwu. This Tengung Kaiwu, it means, history of technology. So this book was written in 1637. It records Tutenag. And in that book, except for Tutenag, it doesn't record anything about zinc. So that means in China, people knew Tutenag. So how they knew Tutenag, how this Indian word reached China? Maybe the idea of zinc reached to China from India. So for that, we need to have a lot of research again. If actually the Chinese learned zinc making from India, actually Chinese zinc making is a different process altogether. We have a downward distillation. Chinese have upward distillation. I'll show you in the coming slide. This I think all of you may be knowing. This is on the left side. It's called Bidri ware of the Bahmanis from Hyderabad, and on the right side are Jittel coins from Himanchal Pradesh. So these are zinc coins actually. Except for these, we do not have zinc coins from India, but of course we do have brass coins. Some later Gupta kings also did brass coins, including Chandragupta II. This Bidri ware has a lot of zinc. So we do not know if this Bidri ware zinc was obtained from China or it was from Zawar itself. This is a matter of research. Of course, unless real objects were analyzed, we cannot conclude from where this zinc came, because by the time when this Bidri ware came into practice in 16th, 17th century, China had also started making zinc. These are Chinese ingots coming to India en route India in early 19th century, at a time when India zinc had almost ceased. This is at that time. So now let us shift to mining area, how zinc was mined. You will surprised to know that, as I said, the Aravallis are very, very important for, it's like polymetallic zone. So we have, mines deep underground mines. Some of the mines are, as deep as 262 meters below the surface. So, below the water table, they knew how to mine. Then in Zawar area where zinc was, largely obtained, there actually, you do find subsurface mining up to a depth of 150 meters. At Dariba also almost equal size of mines, ancient mines you find. So what happens when you are wandering to look for metals or ancient sites? So what happens, generally you come across such, brown, patches in the land. These are actually gosan. These are, the indicators of metals in the subsurface. So that metal is leaching out, and then it is this gosan, this oxide material is visible on the surface. So once it is there, you may understand that this is a metal zone. Anyway, this in Zawar area, this is the map of Zawar, contour map of Zawar area. The sketches, this shaded area is actually the area of ancient mines. There are 2-3 major mining areas, Zawar and Mochia, and this is another Magra. These three areas were largely mined. You can see this river called TD here moving, in zigzag serpentine fashion. And there are whatever you saw the earlier evidence of temples and old Java, it is all in this area. You have large number of smelting locations. Some of them I am going to show you in the coming slide. First, let us understand how this mining was done. So the deep mining was done, and the team which was surveying in that area in 80s think that during the off season when the monsoon was not there, so people were always trying to dewater the ancient mines so that the fresh work could take up. Dewatering must have been a very, very serious trouble in the ancient mines. This is one of the ancient mines. The entrance of it has been now properly protected, and this was our survey pretty early in 2002-3. This is just a sketch by my friend Arvind to explain how mining was done. You have a vertical shaft for ventilation through which air could go in. Then you have working shafts from parallel working areas, which in these working areas are done following the ore. Actually, wherever the veins of the ore move, the working areas would move. And then you have a place for air and light also in between. These are called stopes. So sometimes you have adits. Adits, are made actually to dump the debris of the mining. You need some place so that you can dump something. These are called adits. And then you have sometimes galleries also. Initially for mining, later on these itself become adits. So this is how actually ancient mining was done. More or less in the same fashion, modern mining is also done in the mountains. So these are the ancient mines. Actually, these are vertical mines going down, and then they will have adits, galleries, and stopes side by side. So this is a ventilation shaft actually, just parallel to the mine. This is one of the ancient mine going straight. Now these are some of the Mauryan mines. You can see, they are almost in a curved fashion, semicircular fashion, and this is part of the adit where the dumping has been done. These are the mines actually, and this is the adit area. Well, in some of the mines, you can see, the chisel marks, in the deep, dark areas, you can see the chisel marks also indicating that, how they did mining in the ancient mines. So you have these kinds of, semicircular mining area. They are moving to different directions. Wherever the ore veins were moving, they followed them. This particular mine is having lot of soot. Since they were not only doing fire setting, but also when they must be lighting fire to have some light inside, or lamp. But lamp may not have that much of soot. But when they are doing fire setting, so due to fire setting, maybe this kind of soot is there. For fire setting, actually, Brahmir mentioned in his famous text the use of fire setting, how the rocks were split. So he gives this text. It says that if a rock resists splitting, kindle a fire with fuel from bulia and ebony and make the rock red hot, sprinkling of water with lime over it, and it will burst the rock immediately. So this is a very, very old traditional, also recorded method, which was used at Zawar also, because the evidence of soot indicates that they were also using fire setting. What is important is that thanks to Captain Brook, who was working in Khetri area in North Rajasthan, he recorded how this fire setting was being done. So what he writes that at the mouth of the mine, or at number of places where the rocks were to be broken, So huge heaps of wood was dumped, and when several dumping were done, so they were firing it together. And once firing, so they had to run from those mines because those mines could collapse, and immediately a lot of smoke would, these mines would fill up with smoke. So people may die inside the mines. So I'm talking of area which is about 200 meter or 150 meter from the surface. So they had to save themselves to come out. There were no lifts. There were maybe only some ropes, some ladders, something like this, some stairs to come out. So or people were pulling, each other to save their life. So when they are lighting fire in these mines, they had to run, save their self. This is what very clearly Brook has recorded. Had not Brook done this, we would not have come to know how difficult this fire setting is. My friend Arvind has prepared this sketch. He thinks that people were keeping lamp on their head. Then in deep mines, then because there was no way otherwise they had light. So then they were doing mines slowly, collecting the ore, and then this ore must have been lifted. Okay, in many mines at Zawar, at a depth of 150 meter, 40 meter, 30 meter, or 100 meter, you do have ancient, these ladders. So these stairs actually prepared by wood. This wood has been dated, and that dates back to the Mauryan times. Uh, and you also have launders, channels prepared in wood by cutting wood, and it was very useful for transporting water. Actually, the dewatering the mines and transporting water may have been a very challenging issue in the ancient mines. But the people at Java, they had used all these local methods. This is a sketch prepared by Brenda Caddock. A busy day in the mine. People are taking water. They are taking it up, and then people are collecting water. It is coming down. It is being collected, and people are bringing wood, maybe for fire setting, and people are taking ore in their baskets. It's quite busy. And people have different groups and they have different jobs. So everybody is quite busy. So this is a sketch. This is a plan of the mine. Actually, Lil Millies, Paul Caddock, and others, when they carried underground, L.K. Gurjar, Paliwal Sahab, when they did survey of Agucha and Jawar mines, they prepared this kind of sketch of the mines at Jawar and Agucha. So large, very large mines in these places. These are the iron tools discovered from the mines of Jawar, and there are pointed tools. Then there are things like spade kind of thing. They were being used for mining in Jawar. You have also remains of a basket from Jawar. This has been dated to 3rd century BC. So during the Mauryan times, surely this basket was being used. Also, oh, sorry. Also, you have typical bulb-shaped Mauryan pot from the mines, and this typical bowl, which is clearly Mauryan bowl. These have come from the mines itself. So the mining was being done at Jawar right from the Mauryan times down to early 19th century. It was by 1812, the last mining smelting activity at Jawar was done around 1812. This is a Mauryan mine which in late historic period around 7th century AD worked for a while and then it was abandoned. This has been dated by Caddock. This is an open mine. Apart from underground mines which you saw earlier were about as deep as 150 meters from the surface, and then there are large number of open mines, also very large number of open mines, many of which are very long, about 1 kilometer or even more. So this is one of the open mine at Jawar. This is another open mine at Jawar. You can see these, these hills have mines, the serpentine mines. They have been, if you follow, they are more than 1 kilometer long. Another mine, open mine. Well, these are all mines. This one is Pratap Khan, or known as Pratap Khan. Actually, Maharana Pratap, who is a famous king, is believed to have lived here for a while when he was fighting with Mughals. This is an open mine at Dariba. And you can see this open mine is a huge open mine. When the mine was getting exhausted, so the debris was coming down in the mine. So to hold that debris, they had this kind of wooden revetment. So this wood was dated and it came back to 2200 years old. So this is very, very interesting that 2000 years ago people were able to go about 2262 meters below surface to do mining, and people were making some sort of structures to hold the debris falling to the mines. Arthashastra, interestingly, says the mentions that there was a director of mines during the Mauryan times. Besides the director of the mines, besides being able to identify property of different types of ores and organized mining, he is also expected to conduct the examination of medicinal property of matter in the retorts at the prescribed location. So this last part of the sentence is very, very important. It means they were well equipped, well trained to have some kind of chemical examinations also. So more research is required for this kind of statements. Kautilya also mentions that mines are akara prabhava kosa dandaha prajayate prithvi kosa dandabhyam prapyate kosha bhushanaha. Mines are source of treasury. From the treasury, power comes to state, and the earth whose ornament is treasury acquired by means of army and treasury. What a wonderful statement. So then also again, Arthashastra further mentions dhatu samuttam tajjat karmantesu prayojayet. Profit earned from mine should again be reinvested in the mine to earn further profit. If you are not maintaining the mines, that means the mine will collapse and you will have a great loss. So once you have a loss, your state will be at loss. If you are, it equally applied to the modern mining also. If the modern mines are not maintaining the mines, there will be a great loss to the nation also. So the chronology of mining at Zawar, how it starts during the modern time, of course that is small scale, but then during the medieval time it was in commercial scale, and during the post-medieval time, zinc as well as silver production was done at commercial scale. At Zawar were discovered by Gurjar there is a large dam, reservoir at Zawar. From the filling of the dam, Gurjarji, who was a geologist working with Paul Kadok, and he was in Hindustan Zinc, and he is also, I think, present in this discussion, and he will be very happy to hear this. So he discovered these, coins belonging to Mughal period from the dam fill. These coins, availability of these coins there clearly indicates trade. There is an inscription of King Samar Singh, Maharana Samar Singh, belonging to 14th century. It talks about a mine. Actually, the Maharanas, the local kings, or the descendants or the ancestors of Maharana Pratap, they were all encouraging launching new mines or encouraging mining in this region because they were also having good revenue from the mining. So what happened, in that area of Zawar, actually early this year in January, we heard that somebody is making a house there, and he has destroyed a mound to cut down the foundation of the house. So he had actually, destroyed this area, and part of the mine, part of a smelting furnace, you can see here, the retorts are visible here, they got exposed. So we wrote immediately to the Archaeological Survey of India, and they requested us, Prabhakar said, Prabhakar gave me a call, just, do salvage work so that the retorts and the material is recovered. So all my department students, we went to the place and exposed it properly and recorded the furnace. So here my students are at work. You can see the retorts are kept upside down. The furnace is partly broken here, and we tried to expose it. So now you can see we exposed a furnace floor here. Then we exposed retorts there further down. So actually the upper level of the furnace, there may have been a furnace here. Then this was the floor of that furnace, upper level furnace is already gone. And then the lower part of the lower level furnaces are exposed. And here we have removed the retorts, and these are actually the perforated clay plate. of the retorts after exposing. So these are my students. Now you can see the nozzle here and bottles with nozzle, and you can see the furnace we have exposed. The bottles are kept upside down. Well, what is interesting is in the now the unlike copper, unlike iron, to smelt zinc you have two chambers, upper and lower. Upper chambers had bottles kept upside down like this, and the nozzle would come down. The nozzle would come down through this perforation. Now this plate is about 6 centimeter thick. So and the gap here between the floor and the plate is hardly 10 centimeter or less than 10 centimeter actually. So this altogether is 13 centimeter. Out of this 13 centimeter, this 6 centimeter is already covered by this plate. So remaining 7 centimeter now. So only that 7 centimeter it will be exposed in this, will be in this part of the lower chamber. So within this part, uh, this 7 centimeter has a tremendous work. What is important is in the upper chamber the temperature would be about 1100 degree temperature, and when the vapor is coming down from the nozzle at the end of the nozzle here, so the temperature has to come down to 400 degree. So bringing down the temperature from 1100 to 400 was a miracle. And if it is not, because if you are not able to condense it, if you are not able to bring down the temperature, you will not condense the vapor coming down. The vapor will come down in the form of semi-liquid from the upper part. The moment it comes to the nozzle, end of the nozzle, it will turn into vapor. You have to condense that vapor. That vapor in this area should be collected. Now, if you are not able to bring down the temperature, you will not be able to condense it, and it will turn into powder. So when we saw now if that vapor is falling down in this floor must have some impression. Neither Paul Kadok nor MS University people, when they expose their furnaces, nowhere they could see any kind of impression of that powder falling in the lower floor chamber. Even in our if you see our previous slide, when we expose this floor here, we did not find any impression of that white matter or that zinc falling in this floor. So that means when when the zinc is coming out, when the vapor is getting condensed, when it is coming to the floor, something is kept below this nozzle, and that has been pulled out from the furnace. So from the open area of the furnace, just they pulled it out. So therefore there is no impression here. What was that? Could it be a glass kind of bottle, or could it be a bowl kind of thing in which then there would be 36 or there would be 1? We do not know. So, but what is interesting is what we have noticed in last couple of years while surveying Zawar. In most of the cases, this nozzle is broken. This nozzle is actually should be 13 centimeter, but here even it is just half of that. So the nozzle is in most of the cases is broken. That means the nozzle must be already there in water, either water, there are cups or bowls with water, and when the operation is over, they are just pulling it out so that the condensation is over, and they are collecting the metal and maybe reheating it for some time to remove some more impurities out of it. So what was happening, we do not know. We have to have more research to understand how actually zinc vapor was collected. So therefore I'm saying bringing down temperature from 1100 to 400 here was the miracle. Our Zawar Smiths and the people, those who are bheels, those who are illiterate, did the karama, did the charisma in the metallurgy or history of metallurgy here. So now you see that bank of 7 furnaces here. You see the upper chamber now it has bottles kept upside down, unique bottles made first time in the world, and they were kept upside down. And the lower chamber, the vapor was collected, and it was vapor was turned to powder, condensed. using downward distillation technique, and it was taken out, and the zinc, it was pure zinc with 98% purity, and it was in the powder form actually. So this happened actually at Zawar for almost 800 years, if not more. The Zawar Smith successfully brought down the temperature from 1100 to 400 in the lower chamber to condense the vapor for obtaining pure zinc in the form of powder. Now, apart from Zawar, in whole of our country, apart from Zawar, we do not know even now if there is any other zinc smelting site in India or in entire South Asia. This is the only area of India from where zinc was perhaps being supplied. In recent years, we have heard that there is a place, Kwanu in Himachal Pradesh, where retorts similar to Zawar have been discovered, but we do not still have any evidence of furnaces or evidence like Zawar in that area too. But Himachal Pradesh surely have evidence of zinc ore, and we do have a lot of brass objects from Himachal Pradesh. Maybe people were aware of zinc-rich ore they were smelting for making brass. Now, coming down to Araulis again, what we see in the Araulis, in northern Arauli was actually Ganeshwar culture. The southern was Ahar. And the Hadappans were also coming to the southern margin of the Araulis. So this entire area, on the north, there were again Hadappans. So this entire area, people for last 5,000 years were dealing with metal, and the entire Arauli has been mined like honeycomb mining has been done in this area. So there has been lot of experience of metallurgy. So perhaps this thick experience of metallurgy, and people 5,000 years ago, these Ahar people were able to make pakka, very strong, very impressive defense structures. If you see these Ahar structure, contemporary people across the country, if you go to central India to Malwa, or go to Gujarat, go to Deccan, go to Ganga Valley, you even go to North Rajasthan, you don't have these kind of structures. They were far ahead. No Neolithic people. These were the first farmers in this area using bronze, copper, and making such massive structures in this area. They were using copper, mining copper, and perhaps supplying copper to the Hadappans. Also were able to make beautiful pottery, with glazing effect, and pottery which is very similar to Hadappans. So the prosperity, the outcome of these mines, whatever revenue was coming from these mines to the kings, that huge revenue, out of these revenue only the kings could make large number of massive forts and structures in Rajasthan, in southern part especially. This is the fort of Kumbhalgarh in southern Rajasthan, which is very, very impressive, spread in 36-kilometer area. So making such huge monuments, temples and forts, you need a lot of revenue. That revenue was perhaps largely coming from place like Zawar. You can see this fort, the width of the wall, you can see how impressive it is. Such palaces. Well, the activity of mining, smelting was happening from modern times. This is a place in Zawar itself where the slag is scatter of the slag. It has been dated also. This is again from the Zawar area, Mauryan, from the oxide remain from the Mauryan heap. This is again from lead oxide from Zawar. You can see the magnanimity of the work. When in Rajasthan people were mining and smelting, this is a huge, massive heap of slag in North Rajasthan, copper slag. So now it has been proved by large number of scholars. They have been working. So they have now proved that from this area, Khetri area, copper was being supplied to the Hadapan. This is in very close to Khetri in North Rajasthan, and this way the copper smelting was happening. This air is being blown, and in the furnace constantly charcoal is being given. This was happening in the 18th century or 17th century. Now, the way people smelted zinc at Zawar, the karasma they did at Zawar using downward distillation, a bottle up in the furnace, and the same pattern. There was somebody called William Champion. What he did in 1736, he copied the same apparatus, made an apparatus at Bristol. He also already had a brass making furnace there, but then he did not use it. He used a different apparatus exactly similar to Java. And on the left side is his industry actually. And we do not know how come he realized, he understood this apparatus should be, used for zinc. And he made zinc in 1736. In 1742, he got it patented. Now, see, it is pity that, Indians were making zinc for almost 800 years or even more. But, William Champion just in 1736 started making zinc. 1738, between 38 and 42, he got it patented in England. This was, surprising. We do not know how he learned that. There are of course some European travelers like Supater in 1720. He came to India, perhaps to Rajasthan also. Maybe he had time to visit Zawar when Zawar was already working. Maybe he gave the idea of this kind of apparatus to William Champion. We do not know because there are no clear evidence to this. Of course, Paul Caddock himself clearly writes in his writing that this is notorious copying from India. He clearly writes this. Anyway, this is Chinese and Mongolian technique recorded in Tengung Kaivu in 1637. And this is, Chinese zinc smelting, which is upward. Indians was the downward technique, but in Chinese zinc, smelting distillation is upward. Here the distillation is happening, and in this case, in Mongolian case, the distillation is happening here. I mean, the condensation is being happening here. I mean, the vapor is being condensed here, and in this case, it is being condensed here. So the both Indian and Chinese techniques are different, but interestingly, why and how this Tutenag word traveled to China, that is still a matter of research. There is somebody called Forbes, a very, very eminent European historian of science. In 1964, he writes that it seems that zinc was prepared by Indian chemists since 12th century, but this remained a laboratory experiment and was never applied to industrial production. What you saw at Java, that those massive heaps are surely not, laboratory. They are industrial ones. This is a, distortion of Eurocentrism actually, which should be refuted. Then luckily there is a text by Royal Society about Java. It says at this site are preserved the zinc retort distillation furnaces and remnants of related operations. The technical sophistication and application of scientific principles are unparalleled elsewhere in the medieval period. The elements of standardization and mass production foreshadow the industrial revolution. This is the earliest example of high temperature distillation operation. I repeat, this is the earliest example of high temperature distillation operation. Ruins of exotically carved temples and other village artifacts attest to the success of this metallurgical operation. The operation first applied zinc for brass making. Zinc for brass making used for fine instruments making in Europe, a forerunner of the Industrial Revolution. This is the real certificate to Java, correct certificate. Unfortunately, there is another board given by American Society of Metal immediately after Royal Society. There is some mistake in this. Let me read it. At this site are preserved, in 1988 it was given, it reads, at this site are preserved the zinc retort distillation furnaces and remnants of related operations. The village artifacts, together with temple ruins, attest to the success of this metallurgical technology. This operation first supplied the brass. It is wrong. Should have read zinc, not brass. This operation first supplied the brass for fine instruments making in Europe, a forerunner of the industry. Okay, this is just copy of the Royal Society's text, but they did a mistake. I requested one of the South Indian famous professor who has been associated with the American Society of Metal to get this board corrected. He promised me to do that, but it has not been done so far. Friends, since I am addressing this large audience across the landscape of the country, today this Zawar is in a very pathetic situation. We are losing the remains. How the modern mine is also being operated by the ancient mining area. All the modern mines are just where the ancient mines were. Most of the ancient mines have been blasted by the modern mining work. This is pathetic. If you go to Australia, if you go to Europe, they are minting money out of those ancient mines, just making them tourist places. But our people, our own people, they are blasting those mines. Massive dumping of refractory material is being destroyed. Maybe in coming years, you will not see those massive heaps of those refractory material which I showed you here. Modern mining has also destroyed large number of surface evidence of smelting and habitation. If it is all gone, how tomorrow we are going to say that our ancestors made pure zinc at Zawar at industrial scale for many 100 years, and this stole the show globally and brought big name to the nation. This contributed to the world of science. Now, what happened? There were 2-3 meetings by Archaeological Survey of India in Delhi. I had opportunity to participate them, and I raised the issue of production of Zawar. And thanks to R.S. Bistji, Padaya sir, and Otaji, they strongly not only supported, but Otaji also assured that the Zawar will be soon protected within 6 months. When he was joined DG, he also did the process, and somehow it is still stopped. I do not know what is happening. I spoke to Prabhakarji. Prabhakarji is now excavation director. He is quite interested. I'm sure. I hope he will take it up, take the Kadgal, and there is, because the entire area of Hindustan Zinc is now on the lease with Vedanta Group. They are not interested at all to protect Java. They want to destroy it as early as possible. They don't have to do anything with our heritage. Once we lose it, we have nothing to show to the world. What we did, in the department, since Zawar is, I'm also saying pathetic, because neither it is in the course of archaeology, syllabi of archaeology in the country, nor with metallurgy, nor with engineering, anything. Nobody reads about Zawar. So what we did, we first, of course, surely I brought it into our curriculum. Also, we prepared a furnace exactly on the same dimension of Zawar. So what we to do experiment in our department, we did an experiment, prepared retorts, bottles, this terracotta bottles in our department, bringing soil from Zawar itself, and we prepared perforated plates, bottles, and heat it for 6 hours. But unfortunately, many of our bottles got cracked, and there was white material, of course, on the nozzle part, but we miserably failed. We did roast the ore and grind it properly, mixed with cow dung, prepared balls, and inserted wooden stick in that, and then kept them upside down and heat the furnace for almost 6 hours, but we failed. We did another experiment in IIT Gandhinagar with Alok, and but again we failed. We are planning to do the third experiment. Actually, we still do not know what are the difficulties. So I'm telling this, I'm bringing this to your notice, because in 1812, the Professor Bussell, 1878 to 1778 to 1812, there are many people, many Britishers. They went to Maharana. Maharana even gave money to them. Britishers wanted, they were trying hard to restart the zinc industry when it got seized in 1812 after the Maratha attack. They wanted to restart it, but they miserably failed. By 1842, the last man who knew how to smelt it also died. So that traditional knowledge is died with them. Of course, the modern zinc smelting, the way it's spread from Bristol on the same principle of Zawar, spread to the rest of the world. Actually, it is the same way the condensation is done. Now it is being in India also. But then we wanted to to understand clearly how the zinc smelting was done in the ancient time. So, thus, the zinc smelting process at Zawar appears to be the result of long experience of archaeometallurgy, use of metals in medicine, long history of distillation technology, continuity and transition in cultural processes, and a strong traditional knowledge system in South Asia. All these factors perhaps contributed to the development of underground mining of metals in the first millennium BC and production of pure zinc on commercial scale at Zawar from 12th century CE, if not earlier. Uh, Friends, I therefore salute to the ancient metallurgists of Jawar who stole the show by innovating distillation technique for pure zinc and made India feel proud forever. Uh, there are two, three books available, and of course, there are a number of papers available now on zinc on Java. This is a book I did in 2010, and this is a book done in Hindi by my friend, my student Arvind. And this is a book by Paul Kadok on Java, which has recently come out. So now it can be part of the teaching because now the text is available. I would like to acknowledge the guidance, the help, the teaching of DP, my teacher, mentor DP Agrawal, Rajiv Malhotra ji, Paul Kadok, Grigory Posel, Toshiki Usada, Harihar Paliwal ji, Gurjar ji, Osi Anda Saab, Sahida, our friend, Sharma ji, my colleague Alok Anungo, and some people like Nirmala, my wife, Arvind, my student and friend, Kulsekar ji, KP, Narayan Paliwal, Qureshi, Ramesh Prajapati, many of our students also, they always constantly help me whenever I've been working. And this entire presentation, I would with a humble dedication to my mentor Professor DP Agrawal and Professor B. Lal, who had just entered 100th year of his life. I would like to dedicate this presentation to these stalwarts. Uh, uh, Thank you for the attention, and I hope I was able to communicable.